Have you ever wondered how C++ programming works? Let's take a step back in time to the year 1979. A young computer scientist named Bjarne Stroustrup was working at Bell Labs, a hub of innovation and technological advancement. Stroustrup, inspired by his work on the Unix operating system, began developing what we now know as C++. Originally, it wasn't called C++, but rather C with classes. The name encapsulated Stroustrup's vision to take the efficient and flexible C programming language and augment it with the concept of classes. Classes, a cornerstone of object-oriented programming, allow programmers to bundle data and methods that operate on that data into single units or objects. This was a revolutionary idea that promised to simplify complex programming tasks and promote code reuse. The name C++ came a little later, around 1983. The ++ is a reference to the increment operator in C, a nod to the enhancements Stroustrup's new language brought to the original C. It was a playful way of saying, this is C but better. The influence of C on C++ cannot be overstated. Stroustrup himself has said that C++ would not exist without Dennis Ritchie's innovative work on C provided a solid foundation of syntax and functionality upon which Stroustrup could build. But where C was like a powerful, finely tuned sports car, C++ aimed to be a whole fleet of vehicles, sports cars, trucks, and family sedans, each tailored to a specific kind of programming task. From its birth at Bell Labs, C++ has grown to become one of the most widely used programming languages in the world. Its balance of power and flexibility, its ability to operate close to the hardware level, and its rich set of features have made it a favorite among system software developers, game developers, and many others. And that's how C++ was born, a language initially designed to enhance the C programming language. But how did C++ evolve to be the language we know today, you might wonder? Well, let's embark on a journey through time to understand its evolution. In the mid-80s, a time when computer programming was still a niche interest, the first commercial implementation of C++ was released. The year was 1985, and this marked the beginning of a new era in the world of programming. Developed by Bjarne Stroustrup at Bell Labs, C++ was initially a simple enhancement of the C language, designed to provide programmers with greater flexibility and efficiency. Over time, C++ began to incorporate more advanced features. One of the most significant additions was the concept of templates, introduced in the early 90s. Templates allowed programmers to write generic code, making C++ a more adaptable language that could handle a wider range of tasks. Another important milestone in C++'s evolution was the addition of exception handling in the mid-90s. This feature provided a structured way to manage errors, making the language more reliable and easier to use. But perhaps the most pivotal moment in the evolution of C++ was its standardization by the International Organization for Standardization, or ISO, in 1998. This event solidified the status of C++ as a globally recognized programming language. The standardization ensured that all C++ compilers followed the same set of rules, creating a consistent programming environment across different platforms. Since then, C++ has continued to evolve, with new features and improvements being added regularly. The language has become more user-friendly, with enhancements such as automatic type deduction and lambda expressions making the coding process smoother and more efficient. Through continuous development and improvement, C++ has evolved into a robust and versatile programming language. Its history is a testament to the dedication and innovation of the programming community, constantly pushing the limits of what's possible. As we continue to delve into the world of C++, remember that the language you're learning today is the result of decades of evolution and refinement. Through continuous development and improvement, C++ has evolved into a robust and versatile programming language. Now, let's dive into the core concepts that define C++. As we delve deeper into the heart of this language, we'll find three key pillars that fortify its foundation. object-oriented programming, generic programming, and the use of libraries. First off, let's talk about object-oriented programming, often abbreviated as OOP. This is a programming paradigm that revolves around the concept of objects, which can contain data and code. Data in the form of fields, often known as attributes, and code in the form of procedures known as methods. This enables us to create more organized and flexible code, which can be easily modified and expanded over time. Next up, we have generic programming. This is a style of computer programming in which algorithms are written in terms of types to be specified later. The magic happens when these types are then used during actual use. This means that a single piece of code can work with different data types, making C++ an incredibly flexible tool in the hands of a skilled programmer. Lastly, we cannot forget the importance of libraries in C++. Libraries are like toolboxes filled with pre-written code that programmers can use and reuse, avoiding the need to reinvent the wheel every time they need to implement common tasks or functions. This not only saves time, but also makes the code more reliable, as these libraries have been tested and optimized by many other programmers. These three concepts, object-oriented programming, generic programming, and libraries, form the core of C++. They work in harmony to allow for the creation of efficient, flexible, and reusable code. They empower programmers to solve complex problems, create intricate software systems, and even breathe life into the world of video games. But remember, as with any tool, its power lies not just in its capabilities, but also in the skill of the one who wields it. So, continue to hone your programming skills, explore new concepts, and never stop learning. These core concepts are what make C++ a unique and powerful programming tool. But why is C++ important in today's world, you may ask? Let's delve into that. C++ is like the backbone of many industries, playing a pivotal role in diverse fields. Take game development, for instance. It is the go-to language for creating high-performance games. Its ability to manipulate hardware resources, coupled with its fast execution speed, gives developers the freedom and control to create immersive gaming experiences. Now, let's shift our focus to system software. Operating systems, file systems, network drivers, the heart of these systems often beat with the rhythm of C++. Its direct access to hardware resources and efficient memory management make it the language of choice for low-level programming. Moving on to application software, C++ again comes into the picture. From graphics editors, word processors to databases, the robustness and versatility of C++ make it a favorite among application developers. It offers the flexibility to handle complex calculations and tasks, all the while maintaining a high level of performance. And let's not forget about drivers. Drivers act as translators between the hardware and the operating system. They need to be fast and efficient, and C++ fits the bill perfectly. Its low-level capabilities make it ideal for writing speedy, efficient drivers that keep our systems running smoothly. Beyond its practical applications, C++ is also instrumental in teaching fundamental computer science concepts. It introduces students to the intricacies of object-oriented programming, memory management, and data structures. It's like the training wheels for understanding the nuts and bolts of how software interacts with hardware. But the importance of C++ isn't just about its applications or its role in education. It's also about performance. C++ is renowned for its speed and efficiency. It allows direct manipulation of system resources and provides fine-grained control over memory management, making it a powerhouse of performance. With its wide-ranging applications and performance advantages, C++ continues to be a vital tool in the world of programming. So, what does the future hold for C++? As we journey into the next era of programming, it's clear that C++ is far from fading into obscurity. At the forefront of its evolution is the recent release of C++ 20, a significant update that introduces concepts, modules, ranges, and coroutines. These aren't just new features, they're an overhaul that makes the language more robust and user-friendly. Concepts streamline template programming, while modules dramatically improve compilation times. Ranges simplify the way we work with sequences of data, and coroutines make asynchronous programming more straightforward. But the journey of C++ doesn't end there. The wheels are already in motion for the next wave of innovation, C++23. Although it's still under development, we can expect enhancements like better support for networking and potentially even more improvements to concurrency and parallelism. It's clear that the C++ Standards Committee is dedicated to ensuring that C++ remains at the cutting edge of programming languages. Beyond these updates, the enduring strength of C++ lies in its versatility. It continues to be a language of choice for high-performance computing, game development, and system programming. And looking ahead, it's poised to play a crucial role in emerging fields. Take artificial intelligence and machine learning, for instance. In these areas, performance is paramount, and the efficiency of C++ is a significant advantage. It allows for finer control over system resources, which can be critical when processing large data sets or running complex algorithms. So, as we stand on the brink of a new age in technology, it's clear that C++ will continue to evolve and adapt. Its future is not just about new features or updates, but about how it empowers us to tackle the challenges of tomorrow. It's about how it enables us to push the boundaries of what's possible. As we continue to push the boundaries of technology, C++ will undoubtedly play a crucial role in shaping our digital future.